secretary of this webinar. On behalf of the entire organizing committee, I extend a hearty welcome to all the participants who have joined us today on the third and concluding day of this three-day national webinar on insights into fundamentals of chemistry. Thank you all for joining us today. First and foremost, we extend our gratitude to our respected principal, sir, of C.M.P. Degree College, Dr. Brijesh Kumar, for joining us. Thank you, sir, for being here. We welcome our invited speakers for today, Professor K.K. Upadhyay from Banaras Hindu University, Dr. Neetu Mishra, Head Department of Home Sciences, University of Allahabad, and Dr. Parimita from Warner College of Dairy Technology, Shuats, Prayagraj. Thank you for giving us your precious time. We'd like to welcome our Convener of Chemistry Department, C.M.P. Degree College, Dr. Sunanda Das. Thank you, ma'am, for being here and for giving me this opportunity. We have with us the gracious presence of our senior faculty members of Chemistry Department, C.M.P. Degree College, Dr. A.K. Shukla, Dr. Archana Pandey, Dr. Roli Srivastav, Dr. Babita Agrawal, Dr. Aarti Gupta, Dr. Santosh Srivastav, and Dr. Nidra Tripathi. Thank you all for your constant support and encouragement. I'd also like to welcome our dear seniors and colleagues from Chemistry Department, C.M.P. Degree College, Dr. Deepa, Dr. Pravin, Dr. Vishal, Dr. Pravin Tripathi, Dr. Abhishek, Dr. Pramod, Dr. Sahu, Dr. Ashok, Dr. Ranjit, Dr. Dipanjali, Dr. Monica, Dr. Akram, and Dr. Himani. We are a big department, we are a big family. Thank you all for joining us. We are also grateful to faculty members of other departments of C.M.P. Degree College who are with us today. We have with us Dr. Uma Rani Agrawal from Zoology Department. Thank you, ma'am, for joining us. We are also thankful to faculty members of other constituent colleges of Allahabad University and from institutions from around the country. Thank you all for joining us. We also welcome all the research scholars and students for being with us today. Thank you all for joining. Before proceeding further, there is an important announcement for all of you. Professor Aya Siddiqui, a renowned chemistry expert from Chemistry Department, University of Allahabad, was also supposed to join us today. But because of an unfortunate incident that happened a couple of days ago, he is unable to join us today. But the good news is he is recovering fast, and we pray for his health and speedy recovery. On that note, and as per traditions of our college, we'll start with an opening prayer to Goddess Saraswati. I request Dr. Vishal to please start with the Saraswati Vandana. Vishal sir, please. Thank you, Vishal sir. We'll now proceed with our technical sessions. Our first invited speaker for today is Professor K.K. Upadhyay from Banaras Hindu University, a renowned and eminent expert of chemistry. Our department has had close associations with him earlier, and he has always been there for us. Professor Upadhyay is always full of knowledge to impart and full of infectious energy. I'd like to read out a formal introduction of Professor Upadhyay. He is currently working as a professor in Chemistry Department, Banaras Hindu University, Varanasi. He obtained his graduation, post-graduation, and PhD degree from BHU. He has a long teaching and research experience. He has published more than 60 research papers in journals of national and international repute. One of his research papers in Journal of Molecular Structure was ranked #1 among the 25 hottest articles of this journal in June 2008. His research papers have ranked amongst top 10 most accessed articles in different journals. He was awarded Professor A.K. Day Award in 1992 by Indian Chemical Society, Calcutta. He is actively associated with many different societies and academies. His topic for today's lecture is going to be boranes, structure and bonding. We are very excited to hear from you, sir. Just one information for all the participants. You can post any queries or questions that you may have in the Zoom chat box or in the Facebook comment section. We will pick up your questions from both these platforms and we will ask them on your behalf to the speaker as and when he permits. I now request Professor Upadhyay to take over the session and proceed with his lecture. Sir, kindly unmute yourself. Sir, can you hear me? Sir, can you hear me? So if you can hear me, kindly unmute yourself. Upadhyay sir, can you hear me?
Namaskar to each and everybody. Start करना lecture जहाँ से है वो start. The topic of my today's lecture is boranes, structure and bonding. Am I audible to each and everybody?
Yes, sir. Yes, sir. Please go ahead, sir.
The topic of my today's lecture is boranes, structure and bonding. You see, if somebody asks from an undergraduate chemistry student, what is borane? He or she immediately will say, boranes means diborane. Gentlemen, boranes do not always means diborane. Although diborane is a kind of borane only. If you emphasize, just to elaborate about the boranes, he or she will say boranes means electron deficient molecules. Gentlemen, ladies and gentlemen, I would like to tell you, boranes are not electron deficient molecules. In the classical sense only, they are electron deficient, but in the real sense, they are not electron deficient. Boranes are a class of compounds comprising of several hundreds of compounds, ranging from simple to polyhedral to macropolyhedral types having intriguing structures. As the name suggests, boron is the central element of the boranes. So let us see the position of boron in the periodic table. The position of boron in the periodic table is very crucial in the sense on the left hand side there are metals, while on the right hand side to the boron there are non-metals. At the same time, boron shares diagonal relationship with silicon. So the position of boron is quite crucial. If I define borane in simple words, I can say that boranes are binary compounds of boron and hydrogen. Means in the borane, two components are there, boron and hydrogen. In other words, the boranes are hydrides of boron. And all of us know that there are many elements in the periodic table which form hydrides. So if I compare the number of molecules of the borane, this comes on fourth Fourth, ranking. Carbon forms largest number of hydrides known as hydrocarbons, then phosphorus, phosphanes known as phosphanes, then silicon known as silanes, and after these three hydrides, the number of boron comes known as boranes. Among all the boranes, the most simple one, the most primitive one is BH3. BH3. You see, there are three hydrogen atoms, but unfortunately, this is non-existent. Why this is non-existent? Because this possesses three bonds, three BH bonds, and in all, there are only 6 electrons in the valency shell of the boron. In other words, this does not possess octet in its valency shell. That is why it is electron deficient and it does not exist. It dimerizes into B2H6. That is why among all the boranes, B2H6 is the most primitive one and it is existent also. But this is only one type of borane. The interesting point about the boranes are they are not found in the nature. Their natural abundance is nil. These are always synthesized in the laboratory. Do you know when they were synthesized for the first time? For the very first time, boranes were synthesized in 19th century itself. And what was the method? The method was protolysis of metal borides. If you have a metal boride and you react this metal boride with acid, you will have mixture of boranes. The problem in those days was, although people synthesized boranes, but separation, identification, analysis, these things were not possible. So all these boranes were formed in the form of mixture. They were neither correctly analyzed nor identified. So this was the problem in those days. The first systematic synthesis and study of boranes was performed by Alfred Stock. He was pioneer in this field. You know, boranes are temperature sensitive, boranes are moisture sensitive, boranes are air sensitive. That is why we cannot synthesize boranes in simple laboratory techniques. For the synthesis of borane, Alfred Stock developed, rather I should say, discovered a technique known as Schlenk-line technique. In this technique, reactions are performed at low pressure and low temperature under the atmosphere of nitrogen. So there is a vacuum in the spot. The reactants are put over here. The reactants react with each other under the atmosphere of nitrogen, and you see a low pressure and low temperature, that is vacuum, is maintained. Here the mixture of boranes are synthesized, and once they are synthesized, they get separated into different pots as their melting and boiling points. So Alfred Stock was the first person who used Schlenk-line technique for the synthesis of boranes. Was able to develop the formulae of these boranes. He analyzed these boranes in a proper way. But all of us know that merely analysis is not sufficient. Once knowing the formula, what is the formula of this compound, at the same time, we should also know the placement of different atoms in the molecules, that is structure and bonding. But unfortunately, Alfred Stock was not able to determine the structure and bonding. He limited himself only up to the analysis of these boranes. As far as structure and bonding is concerned, the very first theory of bonding was proposed by Cosell, Langmuir, and Lewis. And this theory is known as octet theory. This theory says that any atom forms bond until and unless that element maintains octet in its last orbit. And if the last orbit is the first orbit, then there should be a doublet. So as per this theory, boranes were tested for their structure and bonding. You see, if I want to understand the structure of diborane, I will have to write this diborane in the form of ethane. You see, in the ethane, in all, there are 8 atoms, and 8 atoms are there, and how many bonds are there? 7 bonds. If I write diborane in this form, then I can write diborane having these many bonds, but a problem will be there, because for 7 bonds, how many electron pairs will be needed? 7 electron pairs. Let us see how many electron pairs are here. At the carbon atom, we are having 4 electrons. So 2 carbon atoms are there. So 2 into 4, on each hydrogen, we have 1 electron. 6 hydrogens are there. So 1 into 6, in all, 14 electrons are there. 14 by 2, 7 electron pairs are there. And since we have 7 bonds, so no problem is here. But here you see, if I write an analogous structure of diborane, there will be a problem for this bond, because each and every borane contains 3 electrons. So 2 into 3 plus 1 into 6, in all 12 electrons are there. 12 electrons means 6 electron pairs. So naturally, if I have 6 electron pairs, I will develop only 6 bonds, and no electrons will be available for this particular bond. So this was the problem with the boranes as far as octet theory is concerned. So it means, but you see, boranes exist. What does it mean? It means that there was something missing in the octet theory. That's why the octet theory was not able to explain the structure and bonding of the diborane. So you see, if I write diborane in this way, BH, 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 you see, boron possesses 3 electrons, 1 here, 1 here, 1 is remaining. Similarly, here also, 1 here, 1 here, 1 is remaining. And hydrogen possesses 1 electron. If I write 2 hydrogens in this form, and remaining 4 hydrogens in this form, then we can develop a solution. You see, but the problem is the centers to be bonded over here, 1, 2, and 3, and electrons are only 2. Similarly, here also, the centers to be bonded over here, 1, 2, and 3. The electrons are only 2. While here, the centers to be bonded over here, 2, and electrons are 2. So here, no problem, no problem, no problem, no problem. Here is a problem. If I assume a bond which binds 3 center, 1, 2, 3, with only 2 electrons, then our problem may be solved. So we can write down the structure of diborane in this way. And in fact, W. Dilthey in 1921, he hypothesized, he put forward the hypothesis of structure of diborane in the form of bridge structure. Just I explained you in the last slide that only 2 electrons are there and 3 centers are to be bonded. So in diborane, 2 types of bond might be there. These bonds are 2 electron, 2 center, 2 electron, 2 center, 2 electron, 2 center, 2 electron, 2 center, while here 3 electron, 2 center, 2 electron, 3 centered bond. So W. Dilthey, he proposed the idea of 2 electron, 3 centered bond in 1921, but there was no experimental evidence, neither experimental evidence nor theoretical footing for this particular type of bond. In 1940, there was a theoretician known as H.C. Longwit Higgins. He proposed the theoretical consideration for banana bond, that is 2 electron, 3 center bond. You see how important boranes are. For boranes, for understanding the structure and bonding of boranes, the theory was modified, and a new theory, the concept of 2 electron, 3 center bond, was added in the octet theory. We can understand the concept of 2 electron, 3 center bond in this way. Suppose 3 atoms are to be bonded with each other. Okay, so there may be 2 ways. The one way is the linear way. 3 atoms may overlap, the orbitals of the 3 atoms may overlap in a linear way, and the orbitals of these 3 atoms may overlap in a triangular way. Suppose if they adopt this linear way, this is first combination. These are the atomic orbitals, atomic orbitals, atomic orbitals, and plus, 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 or minus means symmetry. So this, if plus, plus, plus is there, naturally this will be BMO, bonding molecular orbitals. If minus, plus, and plus is there, the resulting BMO will be NBMO, non-bonding molecular orbitals. And if The overlap is in this way, plus, minus, plus. The resulting BMO will be ABMO. So we will have, since three atomic orbitals are there, so three molecular orbitals will be formed, one BMO, another NBMO, and third ABMO. And suppose if these three atoms, they overlap in a triangular way, what will happen? We will have this BMO, YBMO, because all are positive, same phase overlap, bonding molecular orbital, and this NBMO and ABMO, they will go, they get equalized. Why? Because you see, both are having same type of overlap. If I connect this with this in the triangular way, I am connecting this and this as well as this and this. So these two will be anti-bonding molecular orbitals. Am I right? So in triangular way, we will have one BMO and two ABMO. Means number of anti-bonding molecular orbital will increase if three atoms undergo overlap in a triangular way. Now you see, and the energy level of these two will be equal. One more important point over here is, you see, what happens over here, if the overlap is in linear way, the overlap, and if it is in triangular way, the triangular way is a bit more effective. Why? Because in linear way, this and this, they are not able to overlap. While in triangular way, this, the last two, this and this, they are also able to overlap. Means the potential energy of this bonding molecular orbital will be slightly lower than the potential energy of this way. In other words, what I want to say over here, from here, that if the three atoms overlap in a triangular way, what happens? The bonding molecular orbitals decreases in terms of potential energy. Means it is stabilized a bit as compared to linear overlap. At the same time, number of ABMOs are more. So if I apply this principle on this BHB, you see this one, BHB, okay? So if they overlap in a triangular way, BHB this way, triangular way, so only two electrons are available. If these two electrons are put over here, there will be a bond formation. BHBB, okay? And now you see, suppose had there been more electron in diborane, what would have happened? Those extra electron would have gone into ABMO. Am I right on this point? If diborane would have got more number of electron, then those extra electron would have gone into ABMO. It means that only two electrons are sufficient to fill the BMO when the three atoms of diborane, BHB, they overlap in a triangular way. Okay. Had there been more electron, suppose had there been 13 or 14 electron, then this extra electron would have gone into ABMO, and that would have created instability in the system. So the boranes are not electron deficient, but they are sufficient. And one message from here is, if three atoms are to overlap, the triangular way is a better way than the linear way, because in the triangular way, the resulting molecular orbital is stabilized. At the same time, number of ABMOs are more than BMOs. So you will have to fill less number of BMOs as compared to ABMOs. In 1957, Hedberg and V. Schonecker, they put forward the X-ray crystal structure of diborane. And you see how, up to what an extent Dilthey was correct. You see, in X-ray structure, we got two types of boron hydrogen bonds, BH, shorter bond 1.19, and BH 1.32. Longer bond means less electron density over here as compared to this place, means 2 electron 3 center bond. At the same time, a very weak bond between two boron atoms of 1.77 angstrom. So this was finally solved in 1957 by X-ray diffraction studies. Now, you see, the concept of 2E2C3C bond was added in the classical 2E2C concept of bond for the proper understanding of structure and bonding of boranes. So I took only one example, diborane. As I said initially, boranes doesn't mean only diborane. It possesses hundreds of compounds, hundreds of examples. So in higher boranes, say for example, B6H62 minus, B5H5, B6H10, so on and so forth, there are more than 2 boron atoms. Hence, we may have 2E3C along with 2E2C types of bonds among boron atoms also. In diborane, only 2 borons are there. So 2E2C and 2E3C between BH, boron and hydrogen. In higher boranes, we may have more number of boron atoms. So 2E2C and 2E3C, we may have between boron, boron, boron also. You see, so in all, we may have 5 types of bonds in the boranes chemistry. This one is BH single bond. You see, 2 electron, 2 center. Boron, boron single bond, 2 electron, 2 center. Here you see boron, hydrogen, boron, 2 electron, 3 center, 2 electron, 3 center. This one is boron, 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 2 electron, 3 center. And this may be of 2 types, closed type and open type. What is the difference between the closed type and open type? In closed type, all the borons sp3, sp3, sp3. In the open type, sp3, sp3, 2 borons are sp3, sp3, while 1 boron is overlaps with its p orbital. So this is the difference between the open boron, boron, boron 3 center and closed boron, boron, boron 3 centered bond. Am I right? So in all, there may be a total of 5 types of bonds in the boranes. You see, the higher boranes, where the number of boron atoms are 4 or more than 4, they adopt polyhedral structure. And in the polyhedral, why polyhedral? Because more than 1 faces are there. You see, more than 1 faces are there. And among the polyhedral structure, all are deltahedron. You see, if total number of boron atoms are 4, tetrahedron, trigonal bipyramid, octahedron, pentagonal bipyramid, dodecahedron, tri-capped trigonal prism, bicapped square antiprism, octahedron, and dodecahedron. Now, it is important to understand the difference of a polyhedron and deltahedron. Polyhedron means when a geometrical structure where we have more than 1 faces known as polyhedron. In chemistry, particularly inorganic chemistry, the polyhedra are very, very common. You see, this is a polyhedra, this is a polyhedron. You see, faces are here, and this is also a polyhedron. But the difference between these two is here the faces are square, here the faces are triangular. So those polyhedra where the faces are triangular, they are known as deltahedron. So all the deltahedron are polyhedron, all the deltahedron are polyhedron, but all the polyhedron are not deltahedron. Those polyhedron where the faces are triangular, they are known as deltahedron. Why this deltahedron is important? Because in the borane, the atoms overlap in a triangular way, just to maintain their electron deficiency, just to meet out their electron deficiency. That's why in the boranes, whatever polyhedra is formed, all those are deltahedron. Normally, in the inorganic chemistry, we are very much acquainted with complex. Each and everybody knows complex. Complexes also adopt polyhedral structure. You see, a complex adopts polyhedral structure. Here is a cluster. What is the difference between complex and a cluster? The similarity, what is the similarity? The similarity is both adopt polyhedral structure. But the difference is, here you see, in complex, one metal ion is there, and at the vertex, ligands are there. Okay, there is a bond between metal and ligand. There is a bond between metal and the ligand, but no bond between ligand and ligand. Ligand and ligand, no bond. What about here? Here you see no metal at the center. Here M, 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 or element, 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 element. No, nothing is there at the center. Nothing is there at the center. In another example also, here you see this is a complex, metal at the center, ligand, 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 ligand in the surrounding. These are the bonds. These are not bond. Here, these are the bond. No bond from the central to surrounding. So we can say that complex and cluster are antithesis to each other. What is there? The thing which is real over here, that is imaginary over here. You see this ML bond, ML, here no M, no M. You see, this is imaginary, LL bond, no LL bond. No bond is there between ligand and ligand. Only bond is there between metal and ligand. So this is imaginary, but this is real over here. Here element, 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 element. This is real over here. So it is said that complex and cluster, they are antithesis to each other. The thing which is real over here, that is imaginary over here, and the thing which is real over here, that is imaginary over here. So both are antithesis to each other. So I explained the structure and bonding in diborane. Let us try to have an idea of structure and bonding in a higher borane. And among the higher borane, B6H6, that is hexahydrido hexaborate 2- is very interesting one. You see, in B6H6, there are 6 BH bonds, okay? And all these BH bonds, they are in surrounding, they are in periphery, they are in surrounding. Means the cluster core is constituted of this one. This is the cluster core. And these are outside from the cluster core, BH, they are peripheral bond. And once I say the cluster core, I do mean this octahedral structure, not the surrounding BH bond. So let us see the structure and bonding in B6H6 2-. Let us first of all, let us see how many participating orbitals are there. The total number of orbitals over here is B6. Each and every boron possesses 4 orbitals. Mind it, 4 orbitals, electrons 3, but orbitals 4. So 6 borons are there. So 4 into 6. And each and every hydrogen atom possesses 1 orbital. So 1 into 6. In all, 24 and 6. 30 atomic orbitals are there here. So if 30 atomic orbitals are there, as per bonding theory, 30 molecular orbitals should be formed. Let us see the hybridization state of boron over here. This is the excited state of excited electronic state of boron. 1 electron into S and 2 electrons into P, and the last one is vacant one. So in all, 4 orbitals are there. 3 are having electrons and the last one is not having. Let us see, out of 30, how many are used for the surrounding? Because surrounding one, the surrounding bonds, they do not constitute the cluster core. So out of this 2 into 6, one orbital from hydrogen and 1 orbital from boron. In all, 2 into 6, 12 orbitals are used for peripheral BH bonds. So how many orbitals will be remaining? Total was 30. And out of 30, 12 are used for surrounding one. So remainings are 18. Now let us see how these 18 are distributed. You see, out of these 18, see this one, this one, sweetie, I am not able to see my screen. You see, जरा हटाओ तो ये यहाँ से ये ऑर्बिटल आए तो इसको हटा दो यहाँ से हटाइए यहाँ से हाँ ठीक है ठीक. Now you see the remaining are 18. Let us see how these 18 are distributed. You see, 2 sp orbitals were there of each and every boron. So 1 sp was used for BH bond, and now you see 6 boron atoms are there. So each boron atom is using their sp. In this way, a mega orbital is formed over here, cluster orbital is formed over here. So this is one BMO, first BMO. Now let us see the another orbitals over here. You see, On each and every boron, we have 2p orbitals and both are perpendicular to each other. So out of 2p orbital, ये हटाइए बेटा, इसको हटाइए यहाँ से, ऊपर करिए, इसको ऊपर कीजिए, इसको ऊपर कीजिए, ऊपर कर, हाँ. You see, so 1 sp, 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 all the 6 boron atoms are contributing. So 1 mega orbital is here, 1 BMO from here. Now you see, out of 2p orbitals, both are perpendicular. So you see, this is one BMO, bonding molecular orbital, okay, by the overlap of 2p. And the overlap is in the sigma fashion. You see, end-to-end overlap, end-to-end overlap, end-to-end overlap. So this is one. The another one will be this one, this one, this one, this one. The third one will be this one, this one, this one, and this one. So 3 orbitals from here. Similarly, pi type overlap, 3 orbitals from here. And from here, out of 6, 1 will be bonding and 5 will be anti-bonding. Out of 6, 1 will be bonding and 5 will be anti-bonding. So 1 bonding, 3 from here and 3 from here. So 3 plus 3 plus 1. In all, 7. So 7 BMOs are there. And if total 18 molecular orbitals are there, and out of 18, 7 are BMOs, the remaining 11 will be ABMOs. And here is the distribution of bonding and anti-bonding molecular orbitals. You see, the first BMO formed due to hybridization due to sp hybrid orbitals, this one, and 3 sigma overlap, okay, 3 orbitals. You see this one from here, another from this one, this one, this one, this one, this one. Then third one, this one, this one, this one, this one. So this is 3 sigma type orbital. And this pi type overlap, here also 3 orbitals will be generated, and 1 orbital from here and 5 anti-bonding from here. So 5 anti-bonding, 1 bonding, 3 bonding, 3 anti-bonding, and 3 bonding, 3 anti-bonding. You see, in all, 1 bonding, 3 anti-bonding, 3 anti-bonding. That's 1 bonding, 3 bonding, pi, 3 bonding, and then 3 anti-bonding, 3 anti-bonding, and 5 anti-bonding. And now you see how many electrons are there? How many electrons are there? You see, in B6H6 2 minus, the number of electrons, 3 into 6 plus 6 into 1 plus 2. 3 into 6, now I am counting the electrons. On each and every boron, 3 electrons are there. So 3 into 6 plus 6 into 1 plus 2. So this will be 18 plus 6 plus 2, 26. Out of 26, 12 are being used for BH bonds. You see, out of 26, 12 are being used for BH bonds. So how many remaining? 14. Now you see, if 14 means 7 pairs, you see, 1 pair, first pair, second pair, third pair, fourth pair, fifth pair, sixth pair, seventh pair. So in all, we have 7 pairs of bonding electrons. In all, we have 7 pairs of bonding electrons, and now you see 7 BMOs are also there. 1 BMO, 3 from here and 3 from here. So as many BMOs, that many electron pair. So all the BMOs are filled, and once all the BMOs are filled, this molecule will not be an electron deficient. In any molecule, if all the BMOs are filled, that molecule is never said to be electron deficient. So as I said initially, the boranes are not electron deficient. They adopt a triangular way of overlap, and by that triangular way of overlap, they are electron sufficient, because you see, as many BMOs are there, those many electron pairs are there. Suppose if I ask you how many BMOs and ABMOs are there, in B7H7 2 minus and B12H12 2 minus. In B7H7 2 minus, total number of orbitals on each and every boron 4 into 7, on each and every hydrogen 1, so 1 into 7, in all 35 AOs are there. So 35 BMOs will also be formed. Now you see, out of this 2 into 7 BH bonds are there. So 2 into 7 orbitals for the peripheral bonding for BH bonds, and remaining 21 orbitals for the cluster core bonding. Out of this 21, n plus 1, always n plus 1. As you saw in B6H6 2 minus, there were 6 boron atoms, and n plus 1, 7 BMOs were there. So it is always n plus 1. So if seven boron atoms are there, there will be n plus 1. Eight BMOs will be there. Eight BMOs will be there. And now you see, out of 21, 8 orbitals as BMO and remaining 13 as ABMO. Total number of electrons, 3 into 7 plus 7 into 1 plus 2. Why 3 into 7? 3 on each and every boron. 7 borons are there. On each and every hydrogen, 1. 7 hydrogens are there, and 2 from outside, minus charges there. In all 30. Out of this 30, 7 BH bonds are there. So for 7 BH bonds, for each BH bond, 2 electrons. So for 7 BH bond, 2 into 7, 14 for BH bonds. Remaining 30 minus 14, 16, 8 electron pair. So again, n plus 1. Now you see, in B12, H12, 2 minus, on each and every boron, 4 orbitals are there. 4 into 12 plus 1 into 12, 60 orbital. Out of this 60 orbital, 2 into 12, 12 BH bonds are there, 24 for BH bonds, while 60 minus 24, 36 for cluster core bonding. Out of this, 12 plus 1, 13 will be BMOs, while out of 36, since 12 boron atoms are here, so 12 plus 1, 13 will be BMOs, and 60 and this 36 minus 13, 23 will be ABMOs. Total number of electrons on each and every boron, 3. So 3 into 12, on each and every hydrogen, 1. So 12 into 1 and 2 from outside, 50. So out of 50, 12 into 2 for 12 BH bond, 24 for BH bond, and remaining 26. 26 means 13 electron pairs. You see, 12 boron atoms are there, so n plus 1, 13 pairs are there. Thus, one thing is clear, that due to adoption of triangular way of overlap, less number of BMOs are to be filled in boranes, hence they are able to cope up their so-called electron deficiency. So in the real sense, boranes are not electron deficient. In 1971, Kenneth Wade, along with his co-workers, developed a generalization known as polyhedral skeleton electron pair theory to rationalize internal structural rearrangement of a closed deltahedral borane cluster into nido, arachno, and hypho clusters. As I told you earlier, boranes, particularly the higher boranes, adopt polyhedral structure, and among the polyhedral deltahedral structure, they adopt deltahedral structure. And he was the person, he developed a theory known as polyhedral skeleton electron pair theory. This theory is analogous to VSEPR. For simple molecules and ions, we have valency shell electron pair repulsion theory, VSEPR theory. And for the clusters, particularly for the deltahedral cluster, we have PSEPT. So PSEPT for the clusters and VSEPR theory for the simple molecules and ions. Both are analogous to each other. Kenneth Wade proposed this theory, and as per Kenneth Wade, boranes are of 4 types: Bn Hn plus 2, Bn Hn plus 4, Bn Hn plus 6, Bn Hn plus 8. So where n is equal to number of boron atoms. So if formula is BnHn plus 2, this will be closo, nido, arachno, hypho. Closo means a closed structure, a closed deltahedral structure. And nido means one vertex is missing. Arachno means 2 vertices are missing. And hypho means 3 vertices are missing. Here you see B6H62 minus. This is a closo structure. All the vertices are maintained over here. So this is a kind of closo structure. Next, the important point to be remembered over here is that closo boranes are never found in BnHn plus 2 form. They are always found in their dianion form. These 2 hydrogens, they are never maintained over here. They are always these hydrogens are extra 2 hydrogens are lost, and the 2 minus is always there. What I want to say, BnHn plus 2 never exists in the neutral form, but always in the dianion form. The PSEPT theory, if I give a verbatim statement to the PSEPT theory, the PSEPT theory states that when a p block element forms a deltahedral cluster using its hybrid orbitals by the mixing of its C.M.P orbitals, then n plus 1 electron pairs are required for its cluster core bonding in its closo, nido, arachno, and hypho forms with no 1, 2, and 3 vertices missing respectively. In closo, no vertex missing. In nido, 1 vertex missing. In arachno, 2 vertices are missing. In hypho, 3 vertices are missing. This is the cage structure, this is a nest structure, this is a net structure, and this is more open structure. So you see over here, the number of electron pairs used for the cluster core bonding is same at all the places. All have n+1 bonding molecular orbitals. The only thing is here no vertices are missing. Here 1 vertex is missing. Here 2 vertices are missing. You see 1 vertex is missing. You see this one is missing. This one is missing. Here 2 vertices are missing. The 2 vertices are missing. This one, and this one. 2 vertices are missing over here. And while there, this one, and this one. 3 vertices are missing over there in hypho. Let us see the number of electrons. In V7H7 2-, how many electrons are given by BH for the cluster core bonding? In BH, how many electrons are there? 3 + 1, 4. Out of 4, 2 electrons are used for BH. So remaining 2 electrons will be used for cluster core bonding. So how many BH are there? 7 BH. So 7 into 2. And from outside, 2. 16 by 2. 8 electron pairs. Now you see. Here B6H10, how many BH units are there? As many boron, that many BH. So if 6 borons are there, B6, 6 BH will be there, and 4 hydrogens will be extra one. So here each and every BH contributes 2 electrons for the cluster core. So 6 BH are there, 6 into 2 plus 4 into 1, 16 by 2, 8. Here you see in arachno, 5 B5H11, so 5 BH and 6H. So 5 into 2 plus 6 into 1, 16 by 2, 8 electron pairs. In hypho, B4H12, 4 BH and 8H. So each BH 2, so 4 into 2 plus 8 into 1, 16 by 2, 8 electron pair. So all are having 8 electron pairs. Means all are, the parent structure is this one, n+1, 7, so n+1, 8. The only thing is here all the vertices are intact. Here 1 vertex is missing, 2 vertices are missing, and 3 vertices are missing. So I can read once more the PSEPT theory. The PSEPT states that when a p-block element forms a deltahedral cluster using its Havrod orbitals by the mixing of its C.M.P orbitals, then n+1 electron pairs are required for its cluster core bonding in its closo, nido, arachno, and hypho forms, with no 1, 2, and 3 vertices missing respectively. One more example. Suppose I have taken B6H6 2-, 6 BH units are there. Each BH unit contributes 2 electrons, because although this is BH containing 4, but out of 4, 2 is used for BH and only 2 remains for cluster core bonding. So 6 into 2 plus 2. So 14 by 2, 7 electron pairs. Here B5H9, so 5 BH and 4 extra hydrogen. So 5 into 2 plus 4 into 1, 14 by 2, 7. 7 pairs. In arachno also, B4H10, 4 BH and 6H. So 4 into 2 plus 6 into 1, 7. And in hypho, B3H11, 3 BH and 8H. So 3 into 2 plus 8 into 1. All are having 7 pairs. Means the basic structure is this one. In all, the basic structure is this one. And in this basic structure, all the vertices are intact over here. 1 vertex is missing. Here 2 vertices are missing. Here 3 vertices are missing. So PSEPT applies over deltahedral cluster, and all the boranes, especially the higher boranes, they possess deltahedral cluster. So in boranes, the PSEPT theory of Kenneth Wade applies very well for predicting the type of deltahedra in a particular type of borane. As I told you earlier, the PSEPT and VSEP are both are analogous. Here you can see also. Here in methane, ammonia, and H2O. In all these cases, 4 electron pairs are there. 4 plus 4, 5 plus 3, 6 plus 2. 4 electron pairs are there. And for 4 electron pairs, tetrahedral structure is there. Here you see 4 is also here, 4 is also here. The parent structure is tetrahedral. And in this tetrahedral, 1 vertex is missing over here. That is maintained in the form of lone pair. and 2 vertices are missing over here. 2 lone pairs are here. So this one is the parent structure. This is the kid, first kid, and this is the next kid. Similarly, in boranes also, the boranes adopt polyhedral structure. In polyhedral, especially the deltahedral structure, and in deltahedral one, you see the parent. This is the parent one. This is the kid, next kid, next kid. Closo, nido, arachno, and hypho. So PSEPT and VSER, they are very much analogous to each other. The VSEPR applies for simple molecules and ions, while the PSEPT applies for clusters, particularly the deltahedral clusters. You see, during 1950s, there was a scientist, William N. Lipscomb. He developed a very useful bonding model known as Stites model. And you see, he spent nearly 30-40 years in very serious researches on boranes. First of all, he synthesized the boranes by the method of Alfred Stock, means by the slant line technique. He synthesized full series of boranes. Then he developed their crystals and studied their X-ray structure. With the help of X-ray structure, he generalized the structure of borane, and he developed a theory known as Stites theory, Stites principle. His theory was based on X-ray structural analysis and the theoretical considerations developed by H.C. Longwet Higgins. So in 1976, his work was recognized with Nobel Prize. Let us see the salient features of Stites model. The first point says that there are a total of following 5 types of bonds in the borane chemistry: BH, 2E2C, BHB, 2E3C, boron-boron, 2E2C, boron-boron-boron, 2E3C, open type and closed type. I discussed open type and closed type earlier also. In open type, sp3, sp3 and p orbital. In closed type, sp3, sp3, sp3. Now you see, so all these many bonds are there, but all the combinations are not possible. Here are the allowed and disallowed, or allowed and forbidden combinations. Depending upon the symmetry principles, these are the allowed combinations and these are the disallowed or impossible or forbidden combinations. Means a BHB, 2E3C and 2E3C, their combination is allowed. The combination of boron-boron-boron 3-centered and closed type and boron-boron-boron 3-centered closed type is allowed. Here you see the combination of boron-boron-boron 3-centered and boron-hydrogen-boron 3-centered is allowed. But this type of combination, boron-boron-boron 3-centered and boron-boron 2E2C, not allowed. This is also not allowed, not allowed, not allowed. Due to symmetry regions, these are forbidden combinations, while these many are allowed one. And as per his Stites theory, the second point is a line formula known as semi-topological structure. इसको हटाइए, हाँ ये वाला ऊपर वाला, हाँ इसको हटाइए, हाँ हाँ ये हटाइए. A line formula known as semi-topological structure can be drawn for a particular borane, where in Stites S means total number of BHP 3-centered bond, T means total number of boron-boron-boron 3-centered bond, Y means total number of boron-boron 2-centered bond, and X means total number of BH2 units. Say for example, for B4H10, I can draw this type of line structure. S here, S is the first numeral is S. The first numeral represents S, means total number of BHP bonds. So total number of BHP bonds are 4. 1, 2, 3, 4. The second numeral represents total number of boron-boron-boron 3-centered bond. So you see, number of boron-boron-boron 3-centered bond, no, nil. That's why here 0. And total number of Y represents the third numeral represents Y. Total number of boron-boron 2-centered bond. So boron-boron 2-centered bond 1. And total number of BH2 units 2. You see 1 and 2. Similarly here also, the total number of BHP bonds 1, 2, 3, 4. The total number of boron-boron-boron 3-centered, you see 1. See this one, boron-boron-boron 3-centered bond. The total number of boron-boron 2-centered bond 1, and total number of BH2 units, 1 and 2. Similarly, here also 4120 B5H9. In B5H9, you see S is equal to 4, T is equal to 1, Y is equal to 2, and X is equal to 0. Total number of BH3 bonds 1, 2, 3, 4. This one. Total number of boron-boron 3-centered bond 1. You see this one, this one. Total number of boron-boron bond 2, and total number of BH2 units nil. So this one, if I come to this one, B10H14, you see total number of BH3 bonds 4, 1, 2, 3, 4. Then total number of boron-boron 3-centered bond. You see this one, first one, the second one, the third one, the fourth one, the fifth one. You see this one. This is different one. You see this one, boron 3-centered open type, and this one boron 3-centered open type. Okay, this is BHB bond. This is different than this one. Okay, so 4620. In this way, we are able to draw the line structure formula for a particular borane. This is also known as semi-topological structure. Well, if somebody is giving you Stike's number, you can draw the line structure of a borane. But suppose if Stike's number is not given to you, you know only the formula of the borane, of a particular borane, even then you can derive the Stike's number by the Lipscomb's method. Lipscomb developed 3 equations known as hydrogen valence equation, orbital valence equation, electron valence equation. In hydrogen valence equation, he took S and S and X. Why? Because S involves BHB bonds, all the BHB bonds, and X involves all the BH2 units. So if I add S plus X, total hydrogen will be balanced. Then orbital valence equation, S plus T. S means total BHP, total number of BHP bond, and T means total number of boron 3-centered bond. All the borons which are forming 3-centered bond, definitely they will form 2-centered bond also. So if I count the total number of BHP bond and total number of boron 3-centered bond, naturally this will balance the total number of orbitals. And for the electron balance, total number of BHP bonds, total number of boron 3-centered bond, total number of boron 2-centered bond, and total number of BH2 units, this will be equal to P plus Q. P plus Q, you will have to write the formula of a borane in the form of Bp HP plus Q. So P means this one, and Q means this one. Now you see 3 equations are there, and in the first equation S plus X is equal to Q. If I put this value over here, S plus X is equal to Q, then this equation will be rearranged in the form of T plus Y is equal to P minus Q by 2. Okay, because S plus X is equal to Q. So I have put this value S plus X from here to here. And if I rearrange this Q from here to there, only half Q will be here, and that will be minus. So T plus Y, finally the third equation is T plus Y is equal to P minus Q by 2. So ultimately I have 3 equations. S plus X is equal to Q, S plus T is equal to P, and T plus Y is equal to P minus Q by 2. Ultimately, finally, we have 3 equations, first, second, and this one is third, not this one. This one has been rearranged. Now suppose, let us work out Stike's number for B5H9. First of all, rearrange B5H9 in the form of BP HP plus Q. बेटा इसको हटाइए, ये हटाइए यहाँ से. BP HP plus Q, इसको हटाइए. हाँ. Now you see, so I have rearranged B5H9 in the form of BP HP plus Q. So B5H5 and 4. Hence, S plus X is equal to 4. Okay, BP HP plus Q. So this is the Q. S plus X is equal to Q. So S plus X is equal to 4. Then BP HP plus Q. S plus T is equal to P. So S plus T is equal to 5. T plus Y is equal to P minus half Q. So P is equal to 5 and half Q is equal to half into 4, 2. So 5 minus 2 is equal to 3. So in this way, I have 3 equations over here for B5H9. S plus X is equal to 4. S plus T is equal to 5 and T plus Y is equal to 3. These three are simultaneous equations. Okay. Now let us see how to solve this simultaneous equation. Put the value of S0 from 0 to 5. Why from 0 to 5? Because here in P maximum value of P is 5. That's why you can put the value of S ranging from 0 to 5. So this is the limit. If suppose if in some other borane it is 6, suppose in B6H10, in B6H10 this will be B6H6 plus 4. So here you can put the value from 0 to 6. But since it is B5H9 means B5H5 plus 4. So put the lowest value 0 and the highest value 5. So if S is equal to 0, the values are here. S is equal to 1, the values are here. 2, the values are here. These are the values. Now you see, if I see the values closely, in C, this one, the value, one value is in minus. Here also the value is in minus. Okay. And at the same time, here also the value is in minus. These are nothing, but these are number of bonds. The number of bonds can never be in minus. Okay. This is a common sense. The number of bonds can never be minus. So this solution, this solution, this solution, and this solution, they are hopeless. So these three solutions will be discarded. Only three solutions will be accepted. So those solutions where the any value, any one of the value or any one or any two or any value is in minus, negative, it means that that solution is not hopeful, that is not acceptable, that is hopeless, and that should be discarded. So this one is discarded, discarded, and discarded. So finally, we have three values. S is equal to 1, T is equal to 4, no, this one, S is equal to 2, T is equal to 3, Y is equal to 0, X is equal to 2. Let us draw the structure. This one, here, 2. Here, how many BHB bonds are there? BHB 1 and 2. Okay. How many boron, three-centered bond are here? You see, 1, this is 2, and this one is 3. Everybody, this one is first, this one is second, and this one is third. So total number of boron, three-centered bond, 3. Then number of boron bond, nil. No boron bond is there. There is no bond between two. There is no direct bond between two boron atoms. So this one is nil. How many BH2 units are there? 1 and 2. So you see this one, this one. So this is one structure. Then another Stokes number. S is equal to 3, T is equal to 2, Y is equal to 1, X is equal to 1. You see, number of BHB units 1, 2, 3. Okay. So 3 BHB bonds 1, 2, 3. How many boron, three-centered bond? You see, 1 and this 2. How many boron bonds are there? Okay, you see, boron bond 1. How many BH2 units are there? Only 1. So the formula is 3, 2, 1, 1. You see, here, this is structure 4, 1, 2, 0. BHB bonds 1, 2, 3, 4. Okay, so S is equal to 4. Number of boron bond, 3 boron three-centered bond, 1. Number of boron two-centered bond, this one and this one. And number of BH2 units, no, nil. Okay. Now you see, 3 line structures can be drawn in this way depending upon the Stokes number. And these line structures are known as equivalent structure. Why equivalent structure? Because you see, actually the sum of all these numbers, 2 plus 3 plus 2, 2 plus 3, 5, 5 plus 2, 7, 3 plus 2, 5, 5 plus 2, 7, 4 plus 1, 5, 5 plus 2, 7. All these represent the total number of electron pairs, used for cluster bonding. So that is why they are known as equivalent structure, because all represent equivalent number of electron pairs used for cluster core bonding. You see, once again, I am emphasizing here 2 plus 3 plus 2, 2 plus 3, 5 and 2, 7 electron pairs. 3 plus 2 plus 2, 3, 2, 5, 5 and 2, 7. 4 plus 1 plus 2, 7 electron pairs. In all, 7 electron pairs have been used for the cluster core bonding. The only difference is the permutation and combination. Here, the combination and permutation is different. Here, different permutation and combination. Here different permutation and combinations are. Am I right? So depending upon different permutation and combination, they can write down more than one line structure, equivalent structure for a particular borane. Okay. Now, in the beginning, in the wet theory, I let you know about the polyhedral structure. I told you that boranes adopt polyhedral structure, particularly the deltahedral structure. Okay, the polyhedral structure, they represent the three-dimensional structure, and the line structure represents the two-dimensional structure. Okay, so they are one and same. Okay, say for example, this is B10H14 in the form of stikes. In the form of line structure, this is the structure of B10H14, and in the form of polyhedral structure, this is the structure of B10H14. Okay, you can see 3 plus 2, 2, 5, 5 plus 2, 7, 7. Okay, and ultimately 10 here and 10, B10H14. Similarly, B5H9, B5H9. This is the semi-topological or line structure, and this is the polyhedral structure. So one can say that the line structure is nothing. It is the two-dimensional representation of a three-dimensional structure. All the viewers, all the participants, once I am repeating, you see, this structure, polyhedral structure, represents a three-dimensional structure, while the line structure represents a two-dimensional structure. So the line structure are nothing. They are the two-dimensional representation of a three-dimensional structure of a particular borane. So they are one and same. No difference between two. The only difference is of perception. Okay. The only difference is of perception. Here, how we see the structure. This is 2D and this is 3D. Okay. Ultimately, in the language of chemistry, in the language of the structure, no difference is here. Am I right? Let us see how to what is the pattern of nomenclature in boranes. Boranes are normally found in two forms, either in neutral forms or in anionic forms. If it is in neutral form, how to name the boranes in the neutral form? If it is in the neutral form, what we do, the number of boron atom is indicated by a Greek prefix attached to the root word borane, and the number of hydrogen atoms is indicated by an Arabic numeral added to the word in parenthesis. Say for example, B2H6. Diborane 6. Diborane means 2 boron atoms are there, and 6 in the parenthesis. 6 means 6 hydrogens are here. Pentaborane, if I say pentaborane, 5 boron atoms are here, 5 boron atoms are here. And if I say pentaborane 9, means 9 hydrogen atoms are there. For B6H10, hexaborane 10. Why hexaborane 10? 6 boron atoms are there, and in all a total of 10 hydrogen atoms are there. B8H12, octaborane 12, 8 boron atoms are there and 12 hydrogen atoms are there. B10H14, decaborane 14, 10 boron atoms are there and 14 hydrogen atoms are there. B14H18, so tetradecaborane, borane 18. If it is in the form of anion, as I told you, all the closoboranes, they always exist in the form of anion, particularly dianion. Even other boranes, the nido, arachno, or hypho, they can also form anion, but monoanion, normally monoanion. So suppose if B3H8 minus is there, and suppose I have to name it octahydridoborate 1 minus, octa, 8 hydrogens are here. So here I will not write the number of hydrogen atoms in the parenthesis. These are treated as ligand. Octahydrido, 8 hydrogen in the form of hydride. A octahydrido triborate. Octahydrido, this should be triborate. I have written wrongly over here. Octahydrido triborate. This should be octahydrido triborate 1 minus. Similarly here, B6H6 2 minus, hexahydrido hexaborate 2 minus. Hexahydrido hexaborate 2 minus. This one, dodecahydrido dodecaborate 2 minus. Dodecahydrido dodecaborate 2 minus. Here it should be octahydrido triborate. Okay, please correct it. Types of boranes. Boranes, depending upon their structure, boranes may be of 3 types: lower boranes, higher boranes, and gigantic boranes. Lower boranes are those boranes which are having the number of boron atoms in between 1 and 3. Say for example, BH3, B2H6, B3H11, and all these things. BH3 is non-existent. This does not exist. The existent, the most primitive existent borane is B2H6. Higher boranes, number of boron atoms 4 to 12. If in any borane, number of boron atom is in between 4 to 12, they are known as higher boranes. Say for example, B4H10, B5H11, B6H10, and all this. These adopt polyhedral, particularly deltahedral structure. Gigantic boranes, those boranes where number of boron atoms are more than 12. This portion I did not touch over here, okay, because this is not within the purview of syllabus of MSc, okay. And you will be glad to know that one Indian, Professor E.D. Jain, is a pioneer in this field, and he has developed a theory known as MNO theory. And you will be also glad to know that the Wets theory is a part of Jain's theory. So we have this type of illustrious professor in our country who has given very rich time for solving the intriguing structures of polyhedral, this macro polyhedral structure. He is still alive and active in his field. Let us see the physical states of borane. ये हटाओ बेटा, यहाँ से हटाइए, ये हटाइए, ये हटाइए, यहाँ से ये हटाइए, ऊपर से हटाइए. हाँ, physical states of borane, a very wide window. The diborane and tetraborane are colorless gases. The penta to nonaboranes are colorless liquids. The larger ones, starting with decaboranes, are either colorless or yellow solids. The lower boranes are unstable to heat, pyrophoric, and water undergoes hydrolysis. The resulting solution in water is acidic. In sharp contrast to neutral hydrides, the BnHN2-, that is dianions, closoboranes, particularly B10H10-, and B12H12-, are far more stable, thermally as well as hydrolytically. Their salts can be heated to several hundred degrees Celsius without decomposition. At the same time, they are highly soluble in water to form stable aqueous solution. So here we are having a very wide window, okay, from very low melting point, from very low melting and boiling point to very high melting and boiling point. So this is known as a wide spectrum is here, and these are the I have just summarized the melting and boiling points of a few boranes with me. Now let us see the importance of borane. इसको हटाइए बेटा, आ जा रहा है बार बार, इसको हटाइए यहाँ से, हाँ ये हटाइए यहाँ से, रुकिए, ये हटाइए, हाँ रुकिए, हाँ. You see, importance of borane. As I told you earlier, study of boranes enriched the chemistry in terms of theory and experiment both. The concept of 2E3C banana bond was mooted out and got established in the field of chemistry. So the theory of bonding was modified for having the view of structure and bonding in boranes. So boranes are so important, for them the bonding theory was modified. The same is very useful in understanding the bonding and structure of not only boranes but also of those molecules which were considered to be electron deficient in classical sense. At the same time, discovery of Schlenk line technique by Alfred Stock is very useful for the synthesis of not only boranes but to all those molecules which are air and water sensitive as well as low melting. You see, this fellow is H.C. Brown. He commercialized boranes. Okay, how he commercialized? He used boranes as a reagent in organic synthesis. Okay, all of us know the boranes are very good reducing agent.
There, sir, can you hear me, sir? Sir, we are unable to see your screen, sir. Padre, sir, can you hear me? Sir, can you hear me? Sorry for the interruption. We'll be ready in a few moments.
Theory and experiment both. The concept of 2E3C, a new type of bond, was added in the erstwhile octet theory to just include the other type of molecules which were considered to be, which were supposed to be electron deficient in the classical sense. The knowledge of boranes or the study of boranes is very useful in understanding the bonding and structure of not only boranes, but also there are many molecules which were considered to be electron deficient in classical sense. So this knowledge of 2E3C bond, this knowledge of additional type of bond was very useful in understanding the bonding and structure of those molecules also. The discovery of Schlenk line technique by Alfred Stock is very useful. Even still today it is very useful for the synthesis of not only boranes but all those molecules which are air and water sensitive as well as no melting. All of us know that in chemistry we come across so many molecules which are air sensitive, which are moisture sensitive. So this Schlenk line technique is very useful in the synthesis of those molecules also. A very important reagent, boranes serve as a very important reagent in organic chemistry for the reduction of aldehyde, ketone, ester, lactone, carboxylic acid, as well as addition reaction on unsaturated hydrocarbons, alkenes and alkynes known as hydroboration. And H.C. Brown was pioneer in this field and got Nobel Prize in 1979. So friends, the study of boranes has yielded 2 Nobel Prizes till now. You see, M.F. Hawthorne synthesized a number of metalloboranes, a number of metallocarboranes. These metalloboranes and metallocarboranes, they are wonderful candidates as drug delivery system. All of us know that once we take some drug orally, a major part of this drug is wasted. But if the same drug is taken through a drug delivery system, a very small amount of drug is used. Okay, so the boranes and their derivatives, they are very good candidates and they can serve as drug delivery system also. You see, very recently, the borospherine have come into picture. The borospherine, they are boron analogs of fullerene. All of us know about fullerene, the Buckminster molecule, the buckyballs. And recently, people have prepared the boron analog of fullerene. And not only that, they are preparing its metal complexes, and the borospherine as well as the metal complexes of borospherine, they are very useful in different fields. Initially, I told you that the boranes are pyrophoric in nature, means they get fire very easily. They are air sensitive. So this property is used as rocket fuels. So these boranes, are very good rocket fuels also. So friends, all you have seen that boranes have got a wide range of applications, and the boranes are, they exist in a wide range from gases to liquids to solids. So this is all for today in my talk. I am very thankful to my colleagues of CMP Degree College for inviting me over this platform to share my views on boranes and on boranes structure and bonding. Thank you all. Thank you, each and everybody.
Sir, please stop your screen share.
ओके कैसे
Can-
कैसे कैसे रोकेंगे? स्क्रीन शेयर बंद कीजिए, बंद कर बेटा.
Thank you, sir, for a very informative and interesting lecture. Could you please stop your screen share, sir?
हो गया? स्क्रीन शेयर बंद कीजिए. कनेक्ट कर लो.
So in the top of your Zoom screen, there must be an option for stop share, sir.
Okay, okay. My daughter.
So kindly unmute yourself, sir. We cannot hear you. Yes, sir, it's stop now.
Okay. Okay.
Sir, we have a few questions from the participants. If you permit,
Okay,
please
okay.
ask those. Sir, Rinjin Singh has asked, in boranes, polyhedron structure is more stable or deltahedron structure is more stable?
You see, as I told you, all the boranes, they have always deltahedral structure. Okay, deltahedra are those polyhedra where the faces are triangular. Okay, so all the boranes, they always possess a deltahedral structure. Okay, and all the deltahedra is a polyhedra. Okay, but all the polyhedra are not delta. Am I clear?
Okay, sir. Thank you, sir. So another question, Neha Yadav has asked, which one is more acceptable, complex or cluster structure? Of these two, which one is more acceptable?
Which one is?
More acceptable, sir.
In boranes, clusters are always expected. In boranes, we form the clusters. Okay, and out of cluster and complex, cluster is more stable because in clusters, number of bonds are more.
Thank you, sir. Last question, Ashwini Sharma has asked, in B5H9, P plus Q can be 4 plus 5 or only 5 plus 4?
5 plus 4. 5 plus, because B5, as many boron, that many hydrogen should be there. B5, as many boron, that many hydrogen should be there. B5, H5, and out of 9, since 5 have been used, so 4 are remaining. So B5, H5 plus 4.
Thanks a lot, sir, for a very interesting lecture. The participants are praising you a lot in the comment section. We can see here. Thank you a lot. Thanks a lot, sir.
Thanks a lot for inviting me over this platform. Thanks a lot from here also. Okay.
Thank you, sir. Now we'll proceed with second technical session, and for that I'd like to hand over the reins of this session to Dr. Vishal Srivastav. Sir, kindly continue. Vishal sir, can you hear me? Vishal sir, can you hear me?
Am I audible?
Yes, sir. Yes. Please go ahead.
Okay. Uh, I welcome all of you in this second technical session. Meanwhile, we have some esteemed guests. We have among us our principal, Dr. Bijesh Kumar. Sir, I welcome you. We have two esteemed speakers. One is Dr. Parimita and another one is Dr. Neetu Mishra. Ma'am, I welcome you. As well as we have also Professor Ranjan Desai. Sir, I heartily welcome you in this second technical session of this webinar. First of all, I would like to invite Dr. Parimita to her talk. Here is a brief introduction. Dr. Parimita is an assistant professor at Warner College of Dairy and Technology from Suhat's Prayagraj. She has done PhD in food technology and has been engaged in academics and research from over 16 years. She has also published more than 25 research papers in national and international journals. Her topic for the today lecture is COVID-19 pandemic, transforming the food science industry across the globe. We welcome you, ma'am, and invite you to please start your talk. Ma'am, please go ahead. Ma'am, can you hear me? Dr. Parimita, can you hear me?
Yes, I'm hearing you.
Yes, ma'am. Yes, ma'am. Please go ahead.
Am I audible?
Ma'am, your voice is not clear.
Am I audible now?
Yes, ma'am, but there is some disturbance background.
Am
Ma'am,
I audible now?
Ma'am, please remove microphone. Yes, ma'am. Yes, ma'am. It's okay. It's okay, ma'am. It's perfect.
I am audible.
Yes, ma'am. Yes. Please go ahead.
Okay. Uh, Thank you for inviting me on this prestigious platform. And today's topic of the webinar is the effect on the food service industry by the pandemic, by the COVID-19 pandemic. Actually, it's a tea tsunami. Actually, it's a fallout of food service industry when lockdown was imposed, and now also when unlockdown is there, then also the falling out of food service industry is clear, the crystal clear. The food traffic to the food service, restaurants, bars, anything is reduced up to 70 to 90%. We know that the industry is falling out. So, but changes are inevitable and not always controllable. It is not in our hands to control. Then what can be controlled? It is how you manage, react, and work through these change process. That only comes through how can we manage our reactions, our actions, by understanding the situation, the current situation. We can have management of that particular problem. Now, social distancing, the COVID-19, the new phrases are numerous. We are learning. Everybody is learning new sentences, new phrases, new words, new technical terms like social distancing, COVID-19. These are now on our vocab. Now, I have structured that we look forward through three lenses. There are three lenses to see the effect of COVID-19 pandemic on the food service industry. First is consumer, then second is food service operator, which is providing food, and third is the manufacturer. Now the first, the consumer. First and foremost, consumer is struggling with these transition phase because each and every food service industry is a threat. Now everybody is a threat to health. And so what is the first transition effect? That is the increased use of food home delivery service. Now, this dynamic trial, this is a trial. Obviously, we were acquainted with the home delivery system. We always known the home delivery system of food, but nowadays, but that is not replaceable with the restaurant dining or going out or having street food. This was not the replacement. So this dynamic trial may become or is becoming comfortable. The consumer is becoming comfortable with the service. This higher level of comfort will remain. I think this will remain and translate into greater long-term use of food delivery services. This is the first transition. Second is the thought process, the change of thought process. As we know, the mind is not a vessel. The human mind is not a vessel in which we pour and fill everything. It is a fire to be kindled. So now the fire has been kindled because government and FSSAI both were struggling with the to impose the food safety, the hygiene, the clean street hub initiative. They were struggling with the food service industry's hygiene, sanitation, cleaning, disinfection, and all the aspects of food service industry. But the mentality of the consumer was not changed. So consumer was purchasing things and not questioning the cleanliness and hygiene generally. People are aware, and now this has been dramatically changed and heightened the sense of what they view as safe food handling practices, how their food is grown, what transportation thing is coming, and how it is raised, how it is cooked, how it is processed, how it is packaged. Everyone is inquisitive about this. Everyone wants to know, and everyone is very much aware about that food service operators should use gloves, should not mishandle, and cleanliness indicators like dirty restrooms, that overflowing garbage can. These were for street vendors, the local restaurants. These were the normal things which people don't, they were not aware, they were not even bothered. Everybody was not bothered. Nowadays, people are bothered about these things. Then this is the expanded sanitization behavior which is coming, for which government and FSSAI both were struggling. So this is the blessing in disguise. This is the future of the safe food industry is popping out from this COVID-19 pandemic. Now, the curbside pickup. What is the curbside pickup? It is that we order on phone and our package is ready and we go and pick. It is convenient because everybody don't trust on delivery boy, and delivery is also a time-taking procedure. So people want warm and fresh food. So curbside picking is gearing up, and then the in-dining, when we are going to unlock down, this process is going down. The no-touch high-tech solutions are there. Like digital apps are there. Like QR codes are there. You go into the restaurant, you scan the QR code and menu will be there on your mobile screen. So minimal touch. For the minimal touch, we don't touch the menu cards and etc. we know the no touch solution better in these days uh, for payment options. So these are this this is the transition that food service industry from consumer point of view is facing now. The in foreign countries there is a culture of takeout delivery packaging, but in India this is not the most of the food service operators are using, because in our country the takeout delivery packaging materials are not meant for maintaining moisture, maintaining presentation, and maintaining temperature, the three things which are needed for best takeout packaging to maintain temperature, to maintain moisture, and to maintain the presentation of the food. So this is the new emerging thing that that should be there, that is there, which is evolving, that packaging material should be mattering, and the industry is thinking about this, and the low cost solutions are in pipeline for the packaging, the takeout package, the takeout delivery system is there. Now the consumer is facing, consumer is aware, these are the transition which consumer has faced during pandemic. Now the food service operator, what food service operator is facing, that he is facing a competitive battleground. Why he is facing the competitive battleground? Because he has so many tasks at hand. How many tasks? Because the cleaning, disinfection, sanitization, the proper cleaning, disinfection, and sanitization process and maintenance of hygiene should be followed in the food service industry. The food operator has to incorporate the skilled worker or give training to the workers to know how to maintain hygiene, how to maintain cleanliness, how to maintain disinfection, how to do sanitization during processing of food, during packaging, during delivering, the social distancing. So these are the, this is the first battleground, that downsizing of the staff as well as give skill training to the staff. So, and the other aspect is that consumer is expecting that rate, the price hike should not be there. So this is the battleground that food service operator is facing. Now, other than that, the food service operator is facing the segment shift. Why segment shift? Because travel, sport, entertainment, the social gathering functions, the banquet halls, all are closed and open at very lower pace. So what is there? There is an immense loss. And after that, they have to maintain the protocol of cleanliness, disinfection, sanitization, the proper hygiene, the social distancing. Now they have to manage both type of consumers also, because consumers are of two types. Ones, they are aware that how hygiene should be maintained, and we need that proper hygienic food. We want to maintain no touch, we want to maintain social distance. And other type of consumer is also there, that we are seeing on the roads. Nobody is bothered about wearing mask or maintaining social distance or maintaining proper hygiene. So there are both type of consumers are there, but food service operator have to maintain, have to inculcate both type of consumers and satisfy both type of consumers. So they are on the battleground. So if they need the skilled workers, then also if they need skilled workers, they need the price hike. Non-skilled worker will take lower price and skilled worker will take higher price. And consumer expectation is also there that there is no hike in the price. So food service operator is, and now internationally there are some solutions which are also applied in India, like cloud kitchen. We all are, the cloud kitchen is just the home delivery kitchen, but it has CCTV camera. We all are acquainted with CCTV camera, and we know that CCTV camera, the access of CCTV camera can be on our laptop, can be on our mobile or multiple mobiles. So they are using this feature to assure the consumer that their food is prepared in proper manner, proper hygienic manner, proper nutritious manner. They want to ensure. So they are generating. In Gurgaon, there is also a home delivery kitchen where they have started the cloud kitchen, where they have CCTV cameras for freezer, fridge, the cutting, chopping section, the cooking section. And if you order from them, they will give you the window of that time, the access to their CCTV camera for that time your food is prepared. So you can see how they are preparing, if they have they are wearing gloves or they are having masks or anything like that. You can see, you can pick up by yourself your package. You can see packaging also, and you can pick up your food packet from there by yourself when you know that your food is prepared. And the delivery boy can also deliver the food where the temperature of delivery boy will be mentioned on the receipt, and the time of package given handed over to the delivery boy. So this is the concept of cloud kitchen, in which they are giving this type of servicing for evolving this pandemic. Now there is another concept which has been pushed for transparency in the food service industry internationally. The bigger chains, the bigger hotel chains are providing the supply chain transparency and tracking. How they are doing it? They have made a database of their grocery shopping, when they are shopping, how much they are shopping, and from where they are shopping, what quality they are shopping, when they are using, and the consumer can access. If he or she orders from their list, he or she can access that list to know. Now we can not say that it is an international idea. Why we cannot say? Because we have a very travel dependent economy, and travelers are from all over the world come into India. So if they experience same thing there, they will demand here. So big hotel chains must adopt these things. So these are the transition. This is the transition that food service operator is facing. Now on next transition for food service operator is the increased domestic or local sourcing. As we are seeing that bagal wali dukan, the importance of bagal wali dukan in all social media networks. So because of the transportation lag, because of the supply chain breakage, the food service operators are now thinking of shifting from long distance transportation to short distance transportation for raw material procurement. So these are the things which food service operators are facing. Now, what manufacturers are facing, the transition, what manufacturers are facing, the same that food service operator is facing, the some kind of shift is also there, the transparency and the networking, because the networking issue has become major issue of the supply chain. Where is our transport material? The networking was poor, and because of poor networking, many food service operators, many manufacturers faced several kind of losses. So the new transition is the supply chain transparency and the networking issue to resolve. The networking issue, the better networking, the better communication with the operators, then increased focus on disaster planning, contingency planning, and risk mitigation. How much amount of material, food material can be stored? That planning has become very much important in COVID-19. How much amount of food we can store, because the supply chain breakage is always there. No one knows when the area will be sealed or will become the containment zone, how much amount of food, because food is a perishable commodity. No one can store for longer period of any type of food material. So this is the focus, to plan the contingency, how we will deal with the contingency part. Now, the manufacturer has to face the ready to use products are popular, people are liking, or they are fearing going out, so they need the ready to use product. They are preferring ready to use products, partially cooked products, ready to assemble food options. They need immunity boosters in their food to increase their immunity. So manufacturers have new horizons to think and new transition to evolve. So these are the three things, which three lenses the food consumer, the food service operator, and the manufacturer are facing. We are seeing that seed is blossoming. We are seeing the positive side of our COVID-19 pandemic. What positive changes? Because it is a tea tsunami. Financially, it is a tea tsunami. Everything has been stopped in the COVID-19 pandemic. So we have to think about positive things. We have to evolve as food industry, and we have to think how to manage, react, and work. That's why home catering is a new trend which is emerging. How it is emerging? Whether it is a small marriage ceremony or any ceremony is there, people are loving to have one chef who will come in their house and manage their cooking or prepare food at their home and deliver. But again, if they are positive about that, he is not in the affected area, he is in the safe area. They are preferring home catering. There is an increase in home catering system. ITC, big hotelier chains are providing their chef. They are giving the list of ingredients 1 or 2 days before. You collect that ingredients and they will give you their chef. The chef will come and cook in your home. So how, this is how the effect of pandemic is there, the transition is there in the food service industry. That is my small presentation. Thank you.
Thank you very much, ma'am, for your fruitful lecture. We have learned about cloud kitchen, about food processing during this corona pandemic era. Ma'am, if you grant permission,
Yes,
we have few queries, few questions from our
yes,
participant.
yes, yes, yes.
One question, okay, ma'am. One question is from Vikas Kumar. He is asking that, ma'am, as a wholesale price index, contracts and consumer price index is to be expected rise, what will be the effect on farmers as well as consumers?
There will be an effect
Ma'am, can
on
you hear?
farmers. There will be definitely effect on farmers as well as consumers, but that's what I am saying, that industry has to work out to reduce the price hike, because it is a very important issue and government should bail out the food service industry as it is fallen down, and every tiny member of the society have been indulged in this industry, whether it is a street food vendor or the big hotelier chains.
Okay, ma'am, thank you. Another question is from Abhishek Shoni. Is there any possibility to spread of coronavirus through cooked food?
If you reheat, then it is not a possibility to spread coronavirus. It is advisable that if you have the home delivery of the food, then also you take the food and reheat is up to 75 to 85 degrees centigrade for 30 seconds to 1 minute to eliminate any possibility, because cooking kills corona. So in cooked food, corona cannot be there, but the after cooking contact can be there. So to reduce any type of possibility, just reheat food.
Okay, ma'am. One more question is from Dr. Tanuja Notial. What is the mechanism of cloud kitchen?
It is a simple home delivery kitchen like Domino's. We know that Domino's have kitchen, open kitchen, but with the CCTV camera facility, which a consumer can access from their home. They will have that OTP and the time frame in which their food is being prepared, and they can see each and every activity of cooking.
Thank you, ma'am. Thank you very much for your fruitful and valuable lecture. Again, thank you very much. Now I would like to invite.
Welcome.
Yes. Now I would like to invite our next invited speaker, Dr. Neetu Mishra. Ma'am is Head Department of Home Science, University of Allahabad. Ma'am, I welcome you on behalf of organizing committee. Her expertise area is nutritional biochemistry. She has published more than 45 research papers in national and international journals of repute. She has several years of administrative experience, as well as she is the first lady officer of Allahabad University working as an associate MCC officer and being ranked with lieutenant. Ma'am, I heartily welcome you on behalf of our organizing committee. Her topic for today's lecture is immunomodulatory effects of bioactive compounds. We welcome you, ma'am, and invite you to please start your talk.
Thank you, Vishalji. Thank you so much. I am hardly appreciated because you have given a break to me so that I can be a part of this delegacy. Thank you so much to all the organizing committee members. All the participants have heard a lot of chemistry from yesterday. So I decided to talk on another very light topic, which is actually a demand of today. We have to understand and understand what is the relation between your immune system and nutrition. That is actually required today because anyone who is suffering from deficiency of immune system, whose immune system is not working properly or not protected so much, is going to be a victim of COVID-19. So in this era of COVID-19, I think it's very important to discuss and make people understand who are not from my discipline to understand how nutrition is going to affect your immune system. So technically, the topic is immunomodulatory effect of bioactive compounds. We will try to understand the process of immunomodulation and definitely the effect of bioactive compounds on it. To proceed with immunomodulation is actually a modulation or regulatory adjustment of the immune system. It has natural and human-induced forms that we all understand: the innate and the induced immunity. Innate one, which the nature has given to us from the time we have been given the life, and another one that is acquired, which we achieve from the vaccination or immunization process. So immunomodulation is basically modulation or regulatory adjustment of the immune system. So how bioactive compounds or nutrition is going to affect the process of immunomodulation, this we are going to discuss. So bioactive compounds are what? They are a type of chemical found in small amounts in plants and certain foods such as fruits, vegetables, nuts, oils, and whole grains. Bioactive compounds have actions in the body that may promote good health. I think screen is not getting shared.
Ma'am, wait a minute.
No problem if it is not going to be shared. I can.
The screen share is enabled, ma'am. Can we try again?
Can you see the screen?
No, ma'am. Please try again. Ma'am, your presentation is open or not previously?
Yeah, our presentation is
which
already
you
open.
want to share.
It is to me, but it is not getting shared with you only. Yeah.
Now go through share the screen. First you have to open your presentation. Yes, ma'am.
You can share it.
Yes.
You can see it.
Yes. Please go on a slide presentation.
Good. Now the immune system is responsible for fighting foreign invaders to body like pathogenic bacteria, viruses, and etc. But what is responsible for this? The responsibility is that of a poor nutrition, because poor nutrition increases infection. It slows down it increases the injury process and slows down the healing process. It creates a lot of immune system dysfunction, because of which medical science has established that one of the most important factors in supporting a healthy, balanced immune system is a good nutrition. Now, what are the cells which are basically present in immune system? These are lymphocytes or T cells. These are B cells. These are phagocytic cells. Lymphocytes fight invading molecules directly. T cells form antibodies that can respond to invading molecules or toxins. And phagocytic cells, such as macrophages and neutrophils, they remove the debris created from destroying cells and tissues at the site of infection. Immune system includes soluble factors and cytokines too. Soluble factors are the molecules that can recognize foreign invaders or toxins, and they then try to heal the area of damage and remove the insult from the important body rapidly. Cytokines, on another hand, give signal to immune cells to take up action, but they also often promote an inflammatory response. The inflammatory response at the site of infection is one of the ways how the body secludes or walls off the infected area. Cells of immune system are found circulating in bloodstream or in the lymph nodes. As we know, lymph nodes are present over the entire body, and it is very easy and timely if it is found to be enhanced in volume or in size. It helps in understanding that our immune system is not ready and it is getting somehow infected with autoimmune diseases. Throughout the body, the lymph nodes are available and the immune system themselves are spread throughout the tissues, as we all know. Here, very important thing to understand is the barriers or the helpers which prevent our immune system to get infected. The most important is the skin, and another one is gastrointestinal tract. Gastrointestinal tract is another way of protrusion of skin only. The skin which is outside the body, it is an important barrier and it is considered as the first line of defense, as we have studied even in the school. It is the only part of our defensive barrier. It first of all, it stops any antigen to enter inside the body. Secondly, when we go inside our intestinal tract, it is found to be actually the largest barrier between us and the entire outside world. Gastrointestinal tract is actually an internal skin, but it has about 150 times more surface. As it is in the shape, it is twisted like this and this and this. So more surface than does our outside skin have. It contains the largest number of immune cells of our whole body. That is why it is very much important to make our immune system healthy. Indirectly, we should protect our gastrointestinal tract. The kind of food we give to our intestines, it is decided by that only. See, if we use a lot of refined cereals or refined oil, it is definitely going to harm intestinal barrier. But if we provide a good balanced diet, which I am going to discuss with further, it is definitely going to help out intestinal tract. Gastrointestinal tract actually works in two ways. One, it keeps out damaging molecules and organisms like harmful bacteria and viruses on one hand, and on another hand, it helps in healthy promoting nutrients, molecules and substances, because this is the site from where whatever we have eaten, that particular nutrient, when it goes into its smaller size, that is the most available, like protein gets converted into amino acids and carbohydrate into glucose, and likewise, it is absorbed from all these molecules are absorbed from the same intestinal tract only. So very simple funda is, whether we are providing garbage or good material to our intestine is going to behave in the same manner. So it is very much important to provide healthy food to our intestine first, like food which are high in phosphatidylcholine or its precursors are particularly beneficial in supporting a healthy gastrointestinal barrier. Another part of this presentation is, you must have understood something about, I'm not going to be in very much detail of the immune system, but the focus was only to make you understand that gastrointestinal tract plays a very important role in maintaining your immune system. That is why there is a saying that you should always keep your intestines clean And intestines can only be clean if you are getting good food and good amount of water in your diet every day. The second part of this presentation is the nutrients which are going to support your immune system. So the proteins, the essential fatty acids, vitamins and minerals, including the antioxidants, are the ways to provide protection and strength to our immune system. Many researchers have, over the past various years, have shown that nutrition plays a major role in supporting the production and action of both the cells and soluble factors of the immune system. Let's come to the protein first. Protein, as we all know, it is made of 20 amino acids, and these amino acids actually are required for growth and repair. Some of these amino acids appear to be particularly important for immune functioning. For example, glutamine and arginine. These are being considered as nutrition therapy in pre-surgery patients also because of their stability or their ability to stimulate the immune function. Interestingly, it is not just deficiency of these amino acids that can compromise the immune system. An imbalance of the ratio among these amino acids can also affect the immune response. Nutrition, there is a concept of protein complementarity system. That is, the biological value of protein is to be maintained. Good biological value proteins are required to be the part of everyone's diet. Because all these essential and non-essential amino acids are to be taken in the diet in a balanced ratio. Secondly, vitamins. Vitamins, there are two kinds of vitamins, as we all know, the water soluble and the fat soluble. Water soluble vitamins, among the water soluble vitamins, the B group complex of B complex vitamins and vitamin C both play a very important role in maintenance of immune system. If we talk about vitamin C, it appears to be a support, a decrease in length of time and severity of symptoms associated especially with the upper respiratory viral infections. That is why everyone is talking about eating oranges and lemons, etc., which is high in, means the food which are high in vitamin C, that is the citrus fruit. The basic nature behind the vitamin C is that it can help you in keeping your upper respiratory system out of the viral infection. Likewise, vitamin C also provides antioxidant activity and help in supporting healing power, in enhancing the healing way to lesser the infection at the site of infection. Another in this group is B complex vitamins. These are important in supporting a healthy immune system. These include like vitamin B5, which produce production release of antibodies from B cells. Folic acid, which leads to the decrease in T cells. Vitamin B2 and vitamin B1, that is riboflavin and thiamine respectively, they may impair normal antibody response. And low vitamin B12, as we know, it appears to inhibit phagocytic cells and possibly T cell function. Almost all the food grains and vegetables and fruits can serve as excellent source of these B complex vitamins and vitamin C, which are considered to be water soluble ones. Among the fat soluble groups, vitamin A, vitamin C, and vitamin A and vitamin E are considered to be very good dietary antioxidants. They actually have been shown to impair antibody function and T cell activity. Vitamin K also plays a very important role as it supports a healthy blood clotting ability, as we know. And apart from this, it helps in seclusion of areas of infection and injury in the healing process. Sources of vitamin A, vitamin E, and vitamin K are very common, including mustard greens, turnips, etc. Plants actually contains vitamin A in the form of carotenoids, and animal foods contain vitamin A in the form of retinol. So both sources are very good for maintaining healthy immune system. Other excellent source of provitamin A, that is carotenoids, is leafy vegetables, carrots, sweet potatoes, etc. So concentrated source of vitamin K, which is included as cauliflower, green vegetables, spinach, etc. Hopefully, these all are very good sources of minerals, vitamins, and proteins, and this all are part of Indian food every day. This is the good thing about the Indian food. That is why we are feeling very much safe from the COVID-19 pandemic. Coming to the minerals, zinc is a very important mineral. It is found profusely present in seeds, especially in pumpkin seeds. Zinc is available in a very high quantity. And since zinc participates and helps in maintaining the antioxidant enzyme system of your body, that is why internally your immune system requires not only zinc, but all the other trace elements, especially the selenium, in good quantity. So children, as we see, with severe zinc deficiencies, they show the sign of growth retardation. They show the sign of negative effects of immune system and inhibit the phagocytic cells, macrophages and neutrophils especially. So maintaining adequate but not excessive levels of zinc is important. Excessive level is very difficult to maintain, but somehow if you don't understand the concept of balance between the nutrients, sometimes it happens that deficiency of one of the minerals occurs and excess of one of the minerals occurs in your body. Sources of zinc, as I have already told, maximum seeds have good concentration of zinc in it. Apart from that, lentils, cashews, and quinoa seeds are very good examples of this. Another in this group is iron. Iron deficiency results in impaired response to antibodies, as we know, and defective phagocytic cell functioning also. Copper deficiency, on the other hand, is associated with an increase in infection and may impair development of immune cells as T cells and phagocytic cells. Selenium and manganese, I have already told, they are important in supporting healing from inflammation and maybe immunostimulants. Sources for these have already discussed, but spinach, cumin, turmeric, these are actually very good sources of these minerals. Now coming to the antioxidants and phytonutrients, as they promote healthy immune function, there is a concept of reactive oxygen species. It is very clear and very common to everyone, but then too I want to discuss it in a very small manner that free radicals and damaging molecules, these free radicals actually damage the biomolecules, including the DNA and RNA too. Proteins and the polyunsaturated fatty acids, which are present in our in the outer skin of or in the boundary wall of our cell membrane. So free radicals can damage any biomolecule and likewise produce the diseases associated with all these biomolecules. That is why it is very much important to sequence these free radicals from the body, and antioxidants are the best ways to find these free radicals and help our immune system in quenching these free radicals out of the body. Now the antioxidants are present in very high quantity in our diet if we consume a lot of vegetables and fruits. So the basic sources of antioxidants are basically fruits, vegetables, especially the strawberries, cherries, carrots, tomatoes, etc. So maintaining a healthy balance in our immune system, we should understand that inflammatory response is developed to support healing. But when the response becomes overactive, it can become destructive. That is the reason why we are talking about little exposure of this disease, so that our own immune system can develop an antibody system against this disease. Therefore, healthy immune and inflammatory responses must maintain a balance, a delicate balance to activate protection without causing self-destruction. Along with the nutrients, there is a requirement to maintain a weight management and to provide nutrient-dense food so that our immune system can work in a good manner. Now, coming to the bioactive compounds, especially, we'll discuss it in very small scale, that broccoli sprouts, which are very rich in glucuraphones, tea, which is rich in catechins, garlic, which is rich in allicin, likewise ginger, which contains gingerol and chervol, olive leaves, which contains calcium alonate, mushrooms, which are very high in minerals, berries, which contains polyphenols, especially the anthocyanins, pumpkin seeds, which are rich in antioxidants, as already I have told you, including vitamin C, vitamin B, vitamin E, zinc, etc. Watermelon, which contains an antioxidant called glutathione, which is an integral part of the self-defense mechanism. Probiotics like yogurt and other fermented foods. Spinach, which contains a lot of folate. Sweet potatoes, which contains beta-carotene, and which is converted to vitamin A later. Turmeric, which contains curcumin, ashwagandha, and giloy, which are basically the part of Ayurveda system, but Ayurveda and nutrition work together. Nutrition is alternate therapy mechanism. So giloy, which contains a lot of choline, ethanol, etc., it is a very good therapeutic herb which has the efficacy to fight against the diseases related to immune system. Likewise, cinnamon, which contains cinnamaldehyde, flavonoids, coumarins, etc. Black pepper and tulsi, which is actually worshipped for its endless, miraculous, and medicinal values in everyone's home. Carom seed, which contains thymol, cloves, which contains eugenol, hexane, etc. Cumin seeds that contains terpenoids. This all helps in maintaining. These are the bioactive compounds particularly respectively present in their specific food items. These bioactive compounds combine with the reactive oxygen molecule and they help immune system in quenching out these free radicals from the body and helping out in maintaining a good, healthy nutritional system. Now, there is another concept to understand. That is, as I have discussed, the role of some important food materials as being rich in bioactive compounds. Their bioactive compounds provide protection and strength to our immune system. But one more thing is required to understand, that is, our body actually needs a balance of nutrients to keep itself healthy. We need some nutrients in large amounts called the macronutrients and some in small quantities that are called micronutrients. As per the daily requirement of an individual, there is requirement to maintain a healthy balance between these macro and these micronutrients. Macronutrients, as the name says, these are required in large quantities. These are the carbohydrate, the protein, and fat. Micronutrients are basically vitamins and minerals. So every individual has a different requirement of these nutrients on a daily basis. So we should make a balance. That is the concept of a balanced diet. So all the food groups should be included in the everyday diet in such amounts that it can maintain a balance between these nutrients. And if once a balance is maintained between these nutrients, definitely your immune system is going to work in more profound or more healthier manner. Apart from what till now we have discussed, we can go for some more important points, that we should at least have 6 to 8 glasses of water daily. We should have plenty of fruits and vegetables in our diet daily. Indian spices, which are miraculously important therapeutic agents to provide protection to our immune system should be the part of our daily diet. Wholesome milk, preferably cow's milk. Golden milk is addition of turmeric to the milk, should be the part of our daily diet. Tulsi, ashwagandha and giloy should be added in everyday routine. Kadha or tea made of these herbs and spices available in Indian natural system should be the part, and proper hygiene and sanitation should be the part of daily routine. So the take home message is, we are the part of Indian society and Indian traditional system of living. It's supposed to be a very good, very hygienic and very nutritious system. We should be proud enough and we should adhere to our own traditional system. The pots, the earthen pots and the other metal pots which we were using in the olden days are required to be kept, to be picked out of our boxes and should be used in everyday life. Like the material bronze, which was used in our everyday vessel, it should again come into the court, so that, and the use of tulsi leaves in everyday tea and growing of tulsi leaves as part of our puja system to everyone's house. There was a concept of having a well outside the home where we go, where any outsider or anyone who is coming from outside the home has to go, has to clean its body, at least the hands and the legs, and then only he or she can enter inside the house. It was a very good traditional system of Indian system. Nowadays, we cannot dig a well in everyone's house, but at least we can have a bucket of water outside the home, so that, or at the entrance gate, so that we can wash our hands and they come out with a good hygiene practice inside the house. These are some of the ways to keep ourselves healthy and to support our immune system. So the take-home message is, Indian traditional system is very valuable and very rich heritage. So we should follow it and we should adhere to it. Thank you so much.
Thank you very much, ma'am, for your valuable lecture. And again, I thank you that you spared the time from your busy schedule and deliver a precious talk on this equation. I think we have learned a lot about our immune system, about minerals, entire biochemistry, and how to improve our immune system to fight this corona pandemic. Thank you, ma'am. Thank you very much. Meanwhile, we have among us Dr. Justin Massey from Department of Chemistry, ECC. Sir, I heartily welcome you on behalf of organizing committee. Now it is the time to start our valedictory session. And first, I would like to invite our principal, sir, Dr. Brijesh Kumar from C.M.P. Degree College. Sir, please join us and to say a few words. We welcome you, sir, and request you, sir, to please say few words.
Can you hear me, sir?
Sir, can you hear me?
Yeah.
Welcome, sir.
Can you hear me, sir?
Yes, sir.
Can you hear me properly?
Yes, sir. आप बोलिए.
I feel very honored to be here on the eve of valedictory session of national webinar on insights into fundamentals of chemistry, in which around 1,000 intellectuals have participated. Nowadays, whole globe is facing a great problem in all spheres of life because of deadly coronavirus. This is the reason we have to opt for virtual seminar. By going through the deliberations of various renowned academicians, we came to know that field of chemistry can contribute a lot to fight against the pandemic over whole world. I am very proud of on my all colleagues of the chemistry department who always try to do best in academic as well as in all activities of the college. This is the reason I am very relaxed and don't have any tension regarding overall development of the college. They always put different activities for the betterment of the college. At the last, I wish all the success for the activities to be performed in the later stage. My all wishes to all the participants as well as my colleagues. Thank you. Thank you.
Thank you, sir. Thank you very much for all your blessings and good wishes. I would like to invite Dr. Sunanda Das ma'am, Convener, Department of Chemistry, C.M.P. Degree College, Prayagraj. Ma'am, please say a few words.
Hello. Hello, can you hear me?
Yes, ma'am.
Okay. The voice is clear? The voice is
Yes, ma'am.
clear?
Yes,
Okay.
ma'am. Please go ahead.
Okay, thank you, Vishal. Namaskar to all of you. The best and the beautiful things in this world can't be seen or touched. They must be felt by heart. And thank you is one such prayer amongst them. Respected President KP Trust, Chaudhry Jitendra Singh, Chief Patron of this webinar, Principal Dr. Brajesh Kumar, Patron of the webinar, Chairperson Professor Pravin Kumar Tandon, HOD Chemistry, Allahabad University, Honorable Professors, faculties from various universities and colleges, students, ladies and gentlemen. It is a great honor to propose the vote of thanks who has helped us in making the webinars such a resounding success. This 3 days national webinar from 18 June to 20th June 2020 on insights into fundamentals of chemistry was something like manna from heaven, because when the whole world is struggling with a deadly pandemic and all aspects of human life has come to a standstill, the webinar is an effort to bring academic discussions back to life. The webinar hosted eminent speakers around the country like Professor Shekhar Srivastava, Dean Science Faculty, University of Allahabad, Professor Jagdamba Singh, former Dean, former HOD Chemistry, University of Allahabad, Professor A.K. Jain, Department of Chemistry, DDU Gorakhpur, Professor K.K. Upadhyay, Department of Chemistry, BHU Varanasi, Professor Ranjan Dey, Department of Chemistry, BITS Pilani, K.K. Birla Goa Campus, Dr. Neetu Mishra, HOD Home Science, University of Allahabad, Dr. Parimita Khatri, Warner College of Dairy and Technology, Shuats, Prayagraj. These professors shared their fresh insights into the fundamentals of chemistry by sharing very interesting topics of chemistry. They made excellent presentations, interacted with the students, answered their queries, making the webinar interesting and meaningful. For this, my heartfelt thanks goes to these learned speakers. Professor I.R. Siddiqui could not join us as he met with an accident a few days back. When a motorcyclist hit him and he got many stitches, we wish him a speedy recovery. I would like to express my profound gratitude to Professor Pravin Kumar Tandon, Chief Patron and President KP Trust, Chaudhry Jitendra Singh, Principal Dr. Brajesh Kumarji for gracing the webinar and a very interesting and thought-provoking address, and also for moral support and guidance. I must thank event convener Dr. Pravin Kumar Singh, event coordinator Dr. Vishal Kumar Srivastava, and organizing secretaries Dr. Arjita Srivastava, Dr. Akram Ali, Dr. Babita Agarwal, Dr. Santosh Kumar Srivastava, Dr. Mridula Tripathi. All of them gave their support by efficiently hosting the technical sessions, and also especially for their tireless effort to make this webinar a success. I would like to thank all my colleagues in various committees for their extended support in every aspect to make this webinar a grand success. My special thank goes to Dr. Pramod Kumar for making an outstanding press release. I thank all the people and students all over the country who had participated overwhelmingly. Thank all of you so much. I wish to extend my special thanks to Dr. Puneet Kumar Singh, librarian, C.M.P. Degree College, for his tireless technical support, and Dr. Neeja Kapoor, HOD Zoology, C.M.P. College, for extending her support for sharing the platform. In the beginning of the webinar, we had some hitches as we could not able to connect to our number of participants due to some major technical fault, although later on that was resolved. But my heartfelt apologies goes to them, to those who could not be a part of the first day's technical session. We are going to upload all the 3 technical sessions in a YouTube channel. Everybody can watch that at your convenience. Once again, I thank you all for your cordial cooperation. Thank you.
Thank you very much, ma'am, for your kind words. Now the information from our end to the participant of this national webinar is that they will got their e-certificates from tomorrow via email. On behalf of organizing committee, I thanks to all the participants for joining with us. And now at the end of this webinar, we will play our national anthem and the meeting will be ended by itself. Thank you very much.